presentation. We're going to start with Keith Adams, an old classmate of ours, so great to see him here, from VMware, and then I think we'll go into the Zen folks have got a specific demo, or if they want to talk about the problem in the abstract, then we'll go on to Dan Price, who's our substitute. So, Keith, take it away.
Okay, looks like I just angered something here. Where do I start? Oh goodness. Do we know how to use a map? All these processes. Okay, well let's hope this works. So I'm working on a system called VProbes. And VProbes was inspired by dtrace, but it is not dtrace. And I work at VMware, and we care a lot about running virtual machines. Believe it or not, somewhere I believe there's a. Okay. I'm looking at the same thing I'm seeing in the projection meeting. Let's just make sure there's actually a VMware somewhere. There's actually a VMware somewhere else. So I have a build of VMware Fusion, which is VMware's hosted product for Macintosh running on this thing. And trust me, it's running Windows. So VProbes has some goals similar to dtrace, and some goals slightly different. So user bin vprobe on this system is an interface that will be mildly familiar and a little bit different. So it's listing the probes in this VM. Something like 23,000. The first several ones here are going to be static probes that the virtual machine monitor and VMware device emulation is giving you. For instance, you've got disk I/O start here and disk I/O finish. You've also got in and out, which are the x86's programmed I/O instructions. HV exit, which we'll be playing with in a second. And then you have a gigantic number of kernel entry points. We got these symbols out of the kernel. So sort of, hello world, if you, sort of a useful thing to get out of the way here, since this will be interesting to this crowd. The language isn't deep. It's a little more terse. The syntax similarly is sort of event you want to hook and call back. In this case, the event's VM at 1 Hz, which is an event that happens once a second in the virtual machine monitor. What we're going to do is say hi. We have a slightly different policy mechanism separation on the language than dtrace does. It's my understanding that if you wanted to write scripts in D, you could do it. What you need to do is change the decompiler's backend to emit output that VProbes can reach. Regardless, just to sort of establish that they're working here, which is something interesting, that they can actually get to the UI of this virtual machine. Outstanding, hi once a second. Go tail-f. So a little less trivially, sort of a hi that actually does something. This time we're hooking guest IRQ, which is an event that VMware provides you when a virtual interrupt occurs. The first argument to that thing is the vector of the interrupt. You have if-else, unlike this is a real if-else, you can nest it and do things inside of the if-else and so on. So this thing basically runs a counter every 511 times the counter happens to equal 1F, it tells you what the vector was. So this is kind of a very simple sampling.
Does it support variables?
It supports, it doesn't have the syntax with // but sort of wrapping it around the body of the probe is the equivalent of target. So this gives you sort of a way to crude. Unfortunately, I can't drive load in this thing, so it's just going to be tiny nodes mostly. But so far, it's on my word that there's actually an XP VM running in here, and I swear to you it is. So looking at like a less trivial one, a script we call guest top sort of approximates the top function. This shows our aggregation syntax. It's a little bit different than D's aggregation syntax. A is an aggregating variable. Rather than count, you use ++. But it's a similar sort of write-only hash table with lots of buffering. So the output of guest top, look at it as sort of, you notice I've done the shebang thing here with dash A. Dash A sort of does this dumping of the thing once a second on your behalf. You'll see that it is mostly idle, except it has the VMware tools installed. So they, of course, are chewing embarrassing amounts of CPU. Sorry, I don't work on the tools.
So this actually processes in the Windows.
Yeah, these are user level processes in Windows, right? And basically, how you figure that out for a given VM is you write a little bit of this language that we're still sort of shopping for a name for. But this boils down to a little bit of sort of finding an interesting symbol in the Windows kernel, fishing an offset out of a particular instruction, remembering it, and having a couple of functions that return the right string and the right integer.
So there's any case required tools? Yeah.
No, we're not relying on a guest agent. If I were able to get to the window that is the bloody VM, I would show this running while we rebooted it, which works. And it's kind of a cool thing if you're an OS developer because everybody wants their OS to boot faster, but boot time is always a very hard place to actually make sense of it because you usually by definition don't have a login show. And there are solutions to it, but it's nice that this is the same tool whether the VM is booted or not. So moving along, so far this has basically just been sort of VProbes for Windows, right? Or I should say dtrace for Windows, right? But we are also sitting in the virtual machine monitor, and the virtual machine monitor does interesting things and impacts the performance of VMs in interesting ways. And people are always curious about that, especially developers of VMs like myself. So let's show you something that actually exploits this. This is a sort of So this is a slightly more complicated script. It hooks HVExit. And HVExit is the sort of entry point of the monitor when we're using hardware-assisted direct execution. This is a nice new Intel CPU. It has this wacky BT hardware. And this hardware sort of gives you a magical instruction that says run VM. And that magical instruction won't proceed until the next instruction until the VM boots something. And then this hardware register, VMCS exit reason, that we bridged to a global variable here, tells you what the reason was. And this thing kind of conses up a little string that hopefully tells you why you took an exit. Again, this is going to be a little less fascinating than you hope because this is just an idle VM, but oh well. So yeah, since it's an idle VM, this is kind of interesting. You take a good deal of pointers, right? This is my Mac OS host's time interrupt, essentially. And we could figure out exactly which vector it was if you wanted to crack the registers a little more. You also see a lot of 8-bit rates. So the advanced programmable interrupt controller, Windows, actually like older versions of Solaris, really enjoys talking about that thing a lot. Their system call tends to write it a couple of times. It's doing that to mask out interrupts, but it's a major source of HVExits. The port 70 ins and outs are on the actual timer. So what you're seeing is a bunch of timers, and then the CR3 write happens to be either, well, it's an x86 TLB flush, and the TLB flush could be happening because you're changing address spaces, or it could be happening because you modify the mapping and you actually want to see what happens. So let's see which one of those it is, right? So -C is sort of to put something on the command line. If my VMCS exit code is 28, which if you look at the output up there is what it happens to be. Let's add it on the instruction pointer, right? RAP x86 is in, that's the instruction pointer. Right, reason. So the nomenclature differs for AMD and Intel, and we've spent a lot of time on AMD recently. And so the hope here is that this will tell us whether it's some sort of TLB flushing because it changed a virtual address mapping or because you're just changing processes. So it looks like changing processes is winning. You're writing the page table pointer about 100 times a second, and of those, about 98% of them are swap contacts.
So Keith, you obviously, and in our previous conversations, that you evaluated trying to take dtrace into the hypervisor,
Right.
And you there were some reasons you decided not to do that. Can you elaborate on those so you understand how to?
Yeah, and I apologize, this is kind of Web 1.0 here. You actually have prepared slides. It's mostly for this cartoon. So, this is sort of a really crude version of sort of how all the VMware products work. And it's attempting to shoehorn all of them into the same diagram, so it's kind of goofy looking. The sort of y-axis here is the user supervisor distinction we're used to thinking about. The x-axis is a little weird. Our virtual machine monitor, or VMM, one of the reasons we don't use the term hypervisor, as a lot of other virtualization folks do, is that we don't really have a lowest layer, right? We kind of have a coroutine that's responsible for multiplex with CPU, that we call VMM, that essentially cooperatively shares the host hardware with something that's more traditionally operating system-like. In my case, a Mac OS host. If I was demoing on ESX, it would be the VM kernel, and so on. And the vision here is that we're going to stick probes at the very least in the guest, virtual machine monitor, and also our user level component, which bridges virtual I/O operations to your host. In the case of ESX, hopefully not performance intensive ones, but it's there nonetheless. So the problem here with sort of why not start with dtrace, right? And we thought long and hard about this, and I have legitimate bona fides as a huge fan of dtrace, by the way. You can probably find things on the web where you can prove that I love dtrace in 2004, and it's all true. But dtrace's sort of model is basically that there is a lowest layer, and that's where dtrace resides, and you trap to it with long range instrumentation. And the problem we run into is basically that we don't have anywhere to trap to. Sort of going back to our cartoon here, which of these boxes are you going to port dtrace to? To the guest? Does anybody here work for Microsoft? Serious question, right? But notice, right? Nobody here works for Microsoft. You don't get to port dtrace to Windows. So that's off the table. Do we put in our virtual machine monitor? It's attractive, but our virtual machine monitor is a megabyte of code and data and 3 megabytes of translation cache, and that's it. It's a very, very embedded environment, and it's hard to put complicated things into it. And more to the point, if the VMM is where dtrace lives, you have no synchronous way of getting from the user level half of things into the VMM. The VMM is a continuation-driven program, right? You can't call into it from the user level. And the VMX sounds like a nice place to put it, and it comes close to being a place you could put it. You would be porting dtrace to user level for the first time, but I think that would be doable. The hard part about that is that some of the places we want to put it in the monitor aren't in a position to relinquish the hardware back to the host and from there up to user level. So it's a tough bullet to sort of swallow, and the other thing is that we have a few requirements that we don't necessarily see dtrace having. It sounds like people are going to be talking about these too. One is that some of the applications we want to build on top of VProbes are always going to be tracing. Right? It's not just going to be the sort of worst day of your life where you kick back to VProbes and try and figure out what's going on. There are going to be people running network filters, security applications, and so on that are actually using this as their way of cooking things externally. There's a long, roundabout way of saying that we're going to actually care about running the code and instrumentation fast. And you could, I'm sure you could kick dtrace to try to engineer it so that it cares more about that, right? But that hasn't been a priority thus far.
And is that based on quantitative analysis, or is that just based on?
No, I mean that is based. Yeah, you're right. That is, we didn't build it both ways and measure.
Right, it's true. And
so we do compile that language to native code, right? Those are x86 64 machine code that I'm demoing here.
in terms of always on application, one of the problems we have in dtrace is that because we are in arbitrary contexts, buffer overflows are always possible. Right? You can always attempt to trace data and not actually have the buffer space to store that. Do you guys have that problem, or do you?
We do.
Okay. Yeah. So
if you drive us hard enough, we'll allow memory to.
So any always-on application is going to have to deal with some reasonably sophisticated errors.
Yeah, exactly.
It's the same problem.
The security world is sort of a slightly more analog customer for some of these things than you might think, right? Saying, we did a good job, we did something, and attacks are harder now is often better than saying we did nothing, and attacks are just as easy as that.
So another similar question to Brian's, but there's a another place to draw the line, which is that the question you just talked about was taking the runtime and putting that in various places and saying but there's another actually pretty stable interface between the control data interface between user and interface and all that and the kernel. So to me, actually, a more obvious one for all to leverage everything below that. In other words, why reinvent the compiler, why reinvent the language, and all the rest of it as well?
Right, so, basically because it was cheap and free to reinvent the compiler language, right? Partly because the compiler language aren't as good as the, I think it actually would be easier to graph the back end on the D than it would be to.
Yeah, because it occurs to me that you could achieve everything you were trying to achieve by just taking the IOPCO interface, or even a set of functions that we did put on top of that, and have the same control data interface level and all that. And you can still achieve all your other goals, including even compiling to machine code, because you can simply have it, because you are portable to different environments. You basically take the byte code and just be able to generate object code from that part of the version.
Yeah, so an interesting, so there isn't a byte code here, right? So the interface between, the interface between our user level and this, right, isn't, isn't bytecodes. It's something that's easy to parse, right? Something more like parse code. But yeah, I mean,
But I guess my point is that you can still leverage all our compiler stack, and you can do that transformation either in user level or in the backend of your control interface. Yes, whether, however you express the syntax, fundamentally what we're actually doing is a generic assumption which is translated into another something that
so
I would encourage you.
we've also got if else and we've also got extended looping and we've got some function calls. Right? There's some stuff that probably I agree there's
So I'll wonder. I would say I think your key problem is that it's silly to reinvent the language, the user interface aspect, especially because there's a lot of other things that are.
Yeah, so I don't think the future of anybody using either of these systems is people typing into X terms, right? I don't think the future of either of these systems is Keith knows this language, Mike knows his language, and we do battle in our X terms, right? So at some level, I am really agnostic about how exactly you interface with this mechanism. And frankly, the mechanism, the raw mechanism that we've gotten from the dtrace port, is a tiny fraction of the effort that we need to put. A lot of the effort that we had to put in, which we had to put in the dtrace or VProbes, is things like being able to read virtual memory estimates.
Yeah, I was just going to say, so just dovetail with Andrew's presentation. I mean, it's like where Andrew's looking at also a radically different runtime, a radically different way of constructing the system. I mean, it may be worthwhile if you're asking how we can help one another. I mean, if you do take Mike's suggestion, if you look at taking the, because I think Andrew wants to take the D, wants to take the D syntax and the compile and so on, and be able to make that to his custom runtime.
So if I can just try and get to one briefly, right? So I'm demoing on a Mac, it's running Leopard. Leopard has dtrace in it, right? One sort of obvious thing that you could do with both of these systems that would make both of them more useful is make vprobe probe points and dtrace probe points, right? When you run dtrace-l in the shell in the system, you see a bunch of vprobe probes as well if you happen to be running VMware VMs, and you can write D that instruments them. This is a nice idea. I actually want to do this. I can't demo it yet. However, now I'm going to crap all over that idea. Unfortunately, that descript you write, unless you put some further effort into the Mac OS 10 in kernel runtime, isn't going to be able to read guess virtual or physical memory. And trust me, that is an unbelievably hard gap to try to bridge between the VMM and the kernel.
Because of page faults? Or why is that still hard?
There's no particularly stable mapping between the two.
Because we already did that in DOS. We already in dtrace are able to read visual. It seems to me that's essentially the same problem.
You're doing so through the hardware's TLB, right?
We're doing that to the end. I mean, depends on the architecture, not the size or what it's for.
It does need to be done in software. Right? The VMM was in a different address space than the kernel, and in a different address space than the gas tank. So there's an actual page walker sitting in the VProbe entry, for instance. And the virtual CPU registers, for instance, those funny VT exit registers that we got the exit code out of, Sometimes those things house live guest state, and that's where you need to go to get the current instruction pointer. Sometimes the current instruction pointer, if we're into some sort of slower speed emulation mode that's sitting in the virtual CPU structure. Figuring out where to go to get this information would be a hard gap to bridge. Obviously not impossible, right? I mean, both systems are software, but it's just sort of a question of what you're trying to do here, right? And everybody has this problem, right? It's funny that this is sort of we're a lower level system than dtrace and operators, right? People are out there talking about TCP. TCP is incredibly high level to us, right? We see packets. NFS is unimaginably high level to us, right? That's ethereal, whereas people build entire systems 5 layers deeper than NFS, right? And I claim this is not a reasonable, this is in no way a criticism of dtrace, right? It would not be reasonable to expect dtrace out of the box to be able to do some of this stuff. So, is there some sort of easy way to have both of these systems help one another? And I think there's a way forward here, right? To do so, I'm just going to draw another horrible cartoon, and I apologize, right? You can think of VProbes and dtrace as sort of embodying this pipeline, right? Both of them have some event that happens. The event happens, you run a callback. The callback computes for a while. It either produces output or it doesn't. In the case of dtrace, maybe you predicate your little // thing, short-circuited. In the case of VProbes, maybe it's real state or whatever. You either decide this is worth recording or not recording, you put it in your MP buffer. You can even think of aggregation this way, right? You can even think of aggregation as sort of a buffer, a locally buffered version of this, where every once in a while you dump the contents of your aggregate to one of these aggregate buffers, right? So the provider approach basically you jump the rails on this pipeline at fire time. So if we just sort of made a VProbes provider, bridged VProbe probes to dtrace probe points, what happens is you kind of have these 2 parallel pipelines, which is nice, right? The upper pipeline can do all this wacky VProbe stuff. The lower one can do all this beautiful host-level global visibility stuff, can see what my host is doing, how it's turning into real IOs in the file system and things like that. But you lose the ability to sort of globally correlate them. You lose sort of one place to look at the output. So my sort of modest proposal that I'd like to get across, and I agree there are gigantic complications with doing this, and I don't want to gloss over them, would be what if we hook the output stage instead? What if we run the runtime in parallel, and instead sort of have some, we can think of sort of VProbes as talking dtrace to some extent.
So Keith, that's exactly what Mike was suggesting. So what Mike was suggesting was to hook the output and hook the input. So you take in DOF and you emit EPIDs and data.
Yeah.
So I think it's
exactly. These aren't exclusive, right? I really do want to make VProbes provide that as well.
But the other box, just to be clear, right? The left hand is there's your input query, and then there's getting into the point where you have the instrumentation and the content. So what you're doing is it's exactly your picture. You leverage that part. It's leverage the input query part.
So keep that in mind. If you take a look at DOF, you probably DOF is I don't know how people know what DOF is. DOF is the D object format. This is what the way dtrace actually works. You compile your D into diff, the intermediate format. Then that diff gets lumped together with everything in this object called DOF, which then gets down there in the kernel. So Mike actually invented an entire object format it's a really crisp boundary. And it was one of these problems that it seemed at the time to be incredibly complicated, but it ended up being exactly the right answer. Because it would allow you to go off and do some of that stuff if you wanted to do that. The hook and the DOF.
And while I'm making a fool of myself, I'd also like to point out that you can stack this, right? This problem actually runs the other way too for us. Not only do we want to interact with the host dtrace, we run Solaris guests, and macOS guests, and FreeBSD guests. And they know things we're not interested in relearning. We don't want to re-implement the TCP provider. We don't want to implement box stat, all that good stuff. And it'd be wonderful if sort of we could just stack these things like Lego bricks. Right? There was something, maybe it's already in dtrace, that was sort of a standard you could implement that lets you do stuff like this.
I hope this isn't your next slide, but we've actually talked about stuff like this with the Java group, even right over there. About, there's a lot of domain-specific knowledge that would be really difficult to feel in the kernel, but in the JVM makes a lot of sense. So having another Lego brick, which is your JVM or your Ruby or whatever.
And then you want to actually push it upward into the straight.
But I do think you want the JVM and the Ruby VM to have their own execution engines, right? When you trap into the Solaris kernel, so you can count from a Java virtual machine, something is tragic about that, right?
It can be. There are elements of that which are tragic in that you're inducing more performance overhead than you need to potentially. But there's elements that aren't tragic in that you can then correlate your Java activity with your activity and access to communicate together. It cuts both ways.
So where does that line stop? Because you might have another layers of like that diagram can. So is it then okay to assume that we always have to track on our highest level user application all the way down into the things of the line?
So this is just a question.
I mean, the thing about this picture, right? The thing about having this arrow and not having this arrow is that the compute engine kind of behave like Berkeley packet filter, right? The compute engine kind of choke off things and say, this isn't worth tracking the kernel about. It turns out I don't care about this event, right? So this picture might be more consistent with a world where you don't have to set some sort of go slow flag to run your Ruby VM or Python VM or Java VM, just because you want to use systemic tracing. So anyway, quick plug, VProbes will be in Workstation 6.5, which will be out really soon. Thank you.
I think this point that Richard made in there is kind of the essential point, which is how high up do you need to go? And I think the answer that we have learned at dtrace is as high as you possibly can. That the biggest problems, the biggest performance problems are at the highest layers of abstraction. And the problem is that those represent themselves systematically at the lowest levels of abstraction. So I think if the big challenge to you guys doing virtualization, it's a huge challenge, is if we're going to make good on the promise of virtualizing n machines on the same machine, that those problems, that Ruby problem is first going to manifest itself. Your Twitter calling, throwing exceptions and catching it one frame up is first going to manifest itself at the absolute bottom layer.
So there's absolutely no question you have to integrate up and down across all those layers. It used to be the debate is whether you have the most privileged thing running on the metal be the Uber thing that's receiving all the probes and then integrating them, or whether you have multiple collaborating things integrating those probes together.
And I think that the answer is probably going to be a combination. I mean, it's like if you look at what we've done with JVM and JStack and JVM, it's actually a reasonably good dog. Right, so if you use JStack, it gives you a Java stack backtrace, or John Levin's unbelievably beautiful Python UStack helper, where you can actually get a Python stack backtrace from the kernel. And the way that works is that actually downloads a.
But Brett, ultimately the kernel can see things.
No, I understand. But
the much going through is move the Java object all over creation. Right? The JVM knows that. It's really hard for the kernel.
That's exactly my point. My point is that the kernel can't possibly know how to interpret a Java stack. So we actually have the JVM download a piece of intelligence into the kernel. I'm not saying that
I'm not saying there's intelligence you could download to do this, right? And if I'm wrong, why do we still run JVM? The Sun JVM should go slow flags if you want to use dtrace like JVM.
I mean, well, that's increasingly not true. But if you take Python, for example, the Python UStack helper. I mean, I think I'm trying to actually make a more abstract point that I think you're going to have information. Because you're asking, is it kind of a collaboration? I think it is a collaboration. These higher level systems are going to have to make lower level systems aware of what's going on top, and potentially vice versa.
But does it have to be an actual translation of the logic that is known at the higher level that the kernel can understand kind of if the GC moves or these kinds of things? Or could it be something where you move the execution engine up and actually understands closer to the actual execution of the stuff? And if you want to synchronize or actually correlate information across system, that could be a runtime decision where you're actually merging these things.
And that to me is a $65,000 question. I mean, I think that and the Java guys who were in the room played around with it for a while. I mean, you guys had this idea of like, oh, we're going to take dtrace and dump it into the JVM, and I think that and you can do it that way. That's complicated, and you lose something in the process. I mean, I think it's again.
You also gain a lot in the process, right? You gain that
sure.
A much more capable dynamic execution engine than dtrace or VProbes will ever be able to do. You gain the ability to talk about Java objects and Java terms.
Yeah, all that's true, and this is all great to dovetail into the high-level environments after lunch. So I mean, there's not a single answer to this problem. There are going to be multiple answers to this problem. I would say that one thing that we have found that I think has been interesting, that has been surprising to us, is that you can go a long way on a very small amount of information in these environments. I mean, we thought that the approach we were taking, for example, for Ruby, would be grossly inadequate, be useful or basically not. And the actual answer is because Ruby had essentially no visibility into it prior to the provider that you guys wrote. You've actually made information out of things that are simple. So
the provider-based way is a huge leap forward. I don't mean, this is way, way better than nothing, right? And that's obvious to everybody. But there are things you're going to want to do. When your investigation sort of starts up at the application level, it's hard to sort of talk in C terms, right? The things that you can express as D expressions.
Yeah, I know it's a tough problem. It's a tough problem, and I think that it's going to be, that's going to be the real challenge going forward, especially as virtualization takes off, because you're adding another layer that we're going to have to cross somehow. Yeah, Rich.
This may be more of a problem with instruments than anything else, but my perception of the way that macOS's instruments application works is it really is only designed to look at dtrace probes and only on one machine. And to the extent that there are providers that can either talk about VMs, or talk about Ruby, or talk about networking or other things, or perhaps even stuff happening on other machines, that same front end could be used to give you a global picture and do analysis of multiple things that are interacting.
Yeah, I'd also point out that this sort of idea of running parallel execution engines and then pulling them output is a way forward.
Yeah, absolutely. There's a lot of thought relevant stuff. So, I don't know, the Zen folks, I don't know if you got 2-minute rebuttal. Do you, I don't know if you guys had something specific that you wanted to.
Funny you mentioned bookings, but I'll just...
You should go get stage and introduce yourself as master of helpers.
Benjamin,